Bonsuelo, athletes. It's a great day today. We're going to continue with things that are not equations, with simplifying expressions. And today we're going to talk about simplifying radicals. First thing, real quickly, how do you read something properly and what are you actually trying to do? So you should use proper words. So the first problem there under A is not like 5 rad 32 or 5 radical 32 or anything like it's the fifth root of 32. The second one is not rad 25, radical 25, root 25. It is the square root of 25, or if you want to say the second root of 25, that's fine too. Okay, well, what is it you're trying to actually do? You know, it's not enough to know how to do something. You have to know, like, what you've done after you've done it. So the fifth root of 32 means find the number that when multiplied by itself 5 times will give you 32. Okay, like square root of 25 means find the number when multiplied by itself that will give you 25. It's a pretty simple idea, but make sure you know that's what it is you're actually trying to do. Okay, most of what I'm going to talk about is what do you do when you don't know what to do. So if you're just kind of like looking at a problem and you just know how to do it, do it. Okay, I'm not trying to make this more complicated than it needs to be, although I have to admit it's going to seem like it at times. But when it starts getting complicated is when you don't know what to do. And then I need to show you, okay, what do you do when you don't know what to do? So next thing, notation. The nth root of x to the t power, n is the index or the root. Okay, and then x to the t power is called the radicand. And then t is the radicand exponent. Okay, this is the basic idea when having difficulty. Okay, you take the radicand exponent and you divide it by the index. Okay, so like, what does that look like? If I can give you an example. Okay, what would the 20th root of x to the 800th power be? Well, okay, you may or may not know how to do this, but let's say, I'm assuming you don't. Okay, but what am I asking you to do? What number times itself 20 times gives you x to the 800th? Well, what you do is you take the radicand exponent and you divide by the index, and that gives you x to the 40th. So that means if I take x to the 40th times itself 20 times, I'll get x to the 800th. And that's the basic idea, really. The basic idea is pretty simple, okay? But of course, not all the problems are that simple. So let's take a look at another problem. What if you have this, the 20th root of x, I don't know, let's say to the 803rd power. Well, here's the problem is 20 doesn't divide evenly into x, and 20 doesn't divide evenly into 803. So what we have to do is split the 803 up into things that 20 will divide evenly into, and then whatever's left over. So what's the largest thing in 803 that 20 will divide into? Well, hopefully it's obvious considering we just did the previous problem. So that's x to the 800th power. Okay, well, how much does that leave us left over? X to the third, because remember when you multiply two things, you add their exponents. So that would give us x to the 803rd power. Okay, 20 does divide evenly into the 800, like we did it before. And then whatever you can't do, you just leave it under the radical. There's just nothing you can do with it. So that would give us x to the 40th times the 20th root of x to the third. Now, what does this mean? If I take x to the 40th times the 20th root of x to the third, if I take that whole thing and I multiply it by itself 20 times, I'll get x to the 803rd power. Okay? All right, so that's the basic idea. So again, the thing here is, what do you do when you don't know what to do? You divide the radicand exponent by the index. Okay, well, is it all going to be that simple? No. I mean, the idea is that simple, but all the problems aren't going to be that simple. So here the idea is this is what you do when you don't know what to do. You factor the radicand completely and write it with exponents. Then you separate the radicand. We didn't have to do that in the example I just gave to you. Then you separate the radicand into what you can take the root of and what you can't take the root of. So that's what I did up here, is I separated 803 into x to the 800th and x to the third. Okay? And then you simplify whatever part of the radicand you can divide, and that's what I did up here. I divided the 20 into the 800, and I just left the rest of it under the radical. Okay? So the only part I didn't do up here on this example was the first part, which is factor. Okay, so let's take a look at an example where you need to do that. Okay, here is an example of factoring 80. Now, how did I do this? What I'm going to do is I'm going to take 80, and I'm going to take any prime number. I can take 2, I can take 5. I can't take 10 because 10 is not a prime number. So I'm just going to take 2 and divide it into 80, and that gives me 40. Now, I want to point out something. You don't need to do it in the same order that's in this circled thing. So let's say at this point I go, well, I can divide 5 into that, and that'll give me 8. And I can divide 2 into that, which will give me 4. And I can divide 2 into that, which will give me 2. And as soon as you get this down to a 1, then count up. Okay, I've got 1, 2, 3, 4, 2 to the 4th power times 5. So again, the order in which you do it, as long as you're using prime numbers, it doesn't matter. So what I've done is I've taken 80 and written it as 2 to the 4th times 5. Now, I want to take the cube root of 2 to the 4th times 5. Well, 3 doesn't divide evenly into 4. And the exponent for the 5 is 5 to the 1st, so 3 doesn't divide into that. Okay, so how much of 2 to the 4th will 3, the 4, will 3 divide evenly into? Well, I'm going to split this up into 2 to the 3rd and 2. Okay? And then the 5 just stays 5. Then I take the cube root of 2 to the 3rd, which is 2, because 3 divided into 3 gives you 2 to the 1st, and then the cube root of 10. By the way, something I want to point out, and this is something that's really easy to do not drop the index. You have to keep the index. The answer is not, I'm going to scribble something down and then erase it. The answer is not 2 times the square root of 10. Okay? Because if I multiply 2 times the square root of 10 by itself 3 times, you won't get 80. But if I take 2 times the cube root of 10 and multiply it by itself 3 times, I will get 80. So again, don't do this. Okay, so I'm going to get rid of that. Okay. 2 exponent rules, and then we'll start taking a look at some examples. 2 exponent rules that I want you to be aware of. If I have the root of a times b, that means I can take the root of a and b individually and then multiply them. Same with division. Now, why is this? I've told you this before. Do you see a plus or minus anywhere there? No, you don't. That's what allows us to do this. So I'm going to write something else again, but don't you write it down. What if you have the square root of a plus b? Can I take the square root of the a and the b individually and then add them? No, you can't. Why? Because there's a plus sign there. So you'd actually have to add them and then take the square root. Okay? Okay, now let's just take a look at some examples. First of all, what I went through just now is what do you do when you don't know what to do? Okay? So let's just take a look at the first problem. Square root of 25. What work do I expect you to show for this? Nothing. I mean, square root of 25 is just 5. I mean, it really just doesn't get any simpler than this. Okay? That's it. So don't overcomplicate this. What I'm showing you up here is with this, like the cube root of 80 is what do you do when it's more difficult? Something when you have the square root of 25, what number times itself gives you 25? It's 5. Okay, at this point, I want to address something. And I'm going to scribble some stuff down. Don't write any of this down. Just listen. Okay? Okay. The square root of 25. What am I asking you to do? Find what number multiplied by itself that gives you 25. And so 5 times 5 gives you 25. Fine. And then someone is now saying to themselves, self? But doesn't negative 5 times negative 5 also give you 25? So shouldn't the answer be plus and minus 5? No. Why? And this is just a definition in math. A definition is just an agreement. That's all it is. But mathematicians agree any sort of radical gives you exactly one answer. It will never give you more than one answer. So a square root, actually any even root, you always take the positive one. So yes, I realize 5 times 5 is 25 and negative 5 times negative 5 is also 25. But by agreement, it's something called the principal root. But you don't have to worry about knowing that. But by the principal root definition, you always take the positive one, okay, when you've got an even root. Odd roots we'll get to in a little bit, okay? Now, at this point, you're probably also saying to yourself, self. But I've seen a problem like this before. X squared equals 25. And if you take the square root of both sides, okay, is the answer 5 or is the answer 5 and negative 5? Well, first of all, I've just told you that the square root of 25 is 5, period. That's the only answer, okay, for the square root of 25. And the square root of x squared, see, most people think it's x. It's not, okay? So you've probably seen in the past, I'll come back to this step, that the x squared equals 25 gives you the answer x equals 5 and negative 5. And now I'm going a little bit beyond where we are right now because obviously I haven't gotten to equations yet. I just want to address something that you may be thinking of. And is that true? Is x 5 and negative 5? Yes, it is. The answer to that equation is 5 and negative 5. Okay, well, where does the negative come from? Because I thought the square root of 25 is only 5. Yes, it is. Okay, so where does the negative come from? And again, this is beyond where we're at right now. I'll explain it when we start talking about absolute value. I'll explain it to a certain extent. But the square root of x squared is not x. It's actually the absolute value of x. Now, we haven't solved the absolute value equations yet. But I'm just saying what happens is when you solve the absolute value of x equals 5, you get 5 and negative 5. Now, you don't have to worry about this right now. I'm just trying to maybe answer a question that might pop up. That x squared equals 25, yes, the answer is x equals 5 and negative 5. But the positive and negative 5 doesn't come from the square root of 25. Square root of 25 only gives you 5. The positive and negative comes from the side with the variable. And all I really want to get across is make sure you understand the square root, actually any even root, actually any root at all, only gives exactly one answer, period. The reason why this one gives you two answers because it's an equation, and we'll get to an equations another day. Okay, let's take the fifth root of 32. What number times itself? Oh, by the way, I'm going to erase this because it really is, it's just something I wanted to mention, but I don't really want you to write it in your notes, okay? Okay, what number times itself 5 times will give you 32? And the answer is just 2. 2 times itself 5 times gives you 32. Now, let's say you're looking at this and you don't see how I get this. I'm going to show you the long, tedious way to do it, but I don't expect you to do this. Okay, what do? Factor it. So we've got 32. That gives 16. I'm just going to do this real quick. So that would give us the fifth root of 2 to the 5th. And if you divide the index into the radicand exponent, you get 2 to the 1st, which is 2. Again, you don't have to do that. Okay, so I'm going to get rid of this. You just tell me the answer is 2. But if you want to write that down for your own benefit, go ahead. I'm just going to erase it because I don't expect it. Okay? Okay. What number times itself will give you a negative? There is no number multiplied by itself that gives you a negative. Any even root of a negative, you can't do it. Okay, number 4, the fifth root of negative 32. What number times itself 5 times will give you a negative 2? Well, you can take the odd root of a negative number, because negative 2 times itself 5 times will give you negative 32. Okay, square root of 4/16. Can I take the square root of the top and the square root of the bottom individually? Sure. Why? Because there's no plus or minus anywhere there. So the square root of 4 is 2, square root of 16 is 4, and then we simplify it to 1/2. Now, I'm going to show you something. You don't need to write this down. It's fine with me if you do. It's fine with me if you don't. Could you also have done this? Just simplify the fraction and call 4/16 1/4, and then take the square root of the top and the square root of the bottom. Sure. That's fine. Okay, how about the square root of, or negative square root of 8? The negative's outside the radical, so we can do this. And what am I going to do? I'm going to split 8 up into things I can take the square root of and things I can't. Well, 8's going to be 4 times 2. The square root of the 4 is 2, and the square root of 2 I just leave under the radical. Now, I'm going to show you the long, tedious way to do this. I don't really expect you to do this. As a matter of fact, I kind of don't want you to. I want you to do it the way I just said it, but I would accept it. If you factor 8, again, factor the radicand. Sorry, that's a 4. So that would be the square root of 2 to the 3rd power. Now, I can't divide the index. The understood index is 2. I can't divide that into 3, so I'm going to split this up into 2 squared and 2. Take the square root of 2 squared, will give you 2, and the square root of 2 is left over. Again, that is a long, tedious way. I don't really want you to do it that way. You may, but it's much easier to say 8's 4 times 2. So again, I'm going to get rid of this. Okay. All right. Square root of 200. I'm going to show you the easy way, then I'm going to show you the hard way. Okay, what can I split 200 up into? Well, what's in 200 that I can take the square root of? 100. So what's the square root of the 100? 10. And what's the square root of 2? You can't do anything, so it's just square root of 2. Now, again, I'm going to show you the long, tedious way of doing this, and I don't expect you to do this, but let's factor 200. Okay, well, first of all, there's a 2. I'm just going to try and rip through this as quickly as I can because, again, I don't really expect you to do this. You may. So that becomes the square root of 2 to the 3rd times 5 squared. Okay, so I can't take the square root of 2 cubed, so I'm going to split up into 2 squared and 2. The 5 squared's fine. So I take the square root of the 2 squared is 2, the square root of the 5 squared is 5, and the square root of 2 is left over, and you get 2 times 5 is 10 times the square root of 2. Way more complicated. But again, that's what you do when you don't know what to do. Okay? So it's long, it's tedious, it's unnecessary, but it's fine if you want to do it that way. But I'm going to get rid of it. Okay. Next one, the cube root of 625. Again, I'm going to show you the quick way. Okay, what number in 625 could I take the cube root of? 125, and then that'd be times 5. That gives you 625. Cube root of 125 is 5. And again, don't drop the index, times the cube root of 5. Okay, how would you do this if you didn't see that? Again, I'll just show you down here, and then I'm going to erase it. Okay, we'll take 625. We'll put 5 into it. And again, I'm going to shorten this up a little bit. That's 5 to the 4th, which 3 doesn't divide evenly into 4. So I'm going to call this 5 to the 3rd times 5. Cube root of 5 to the 3rd is the 5, and then the cube root of 5 is left over. So if I take 5 times the cube root of 5 and multiply it by itself 3 times, I'll get 625. Again, that's the long, tedious way of doing it. If you need to do that, that's fine, but I'm going to get rid of it. Okay. Square root of 3 times square root of 6, which is, I'm going to show you the way most people are going to do this, and then I think I'm going to show you a little bit better way. Okay, so most people are going to call this square root of 18, and then 18 is 9 times 2, and then that'd be 3 square root of 2. Fine. What do I think is a little better way? I like to leave things factored. So I'm going to put them under the same radical, but the 3 stays 3, and I'm going to factor the 6 into 3 times 2. And then the square root of the 3 squared is 3. Okay? I don't like to multiply things together. I am multiplying them. I'm putting them under the same radical, but in factored form. The square root of 7 squared, hopefully that's just 7. Okay? Now, take a look at number 11. Most people are going to want to multiply 18 and 80. Well, that's going to give you some huge number. So I'm going to do the same thing I did in number 9, but the second way I did in number 9, and that is leave it factored. Okay, well, 18 I can call 9 times 2. 80 is going to be 16 times 5. Okay, so we got the square root of 9 is 3. The square root of the 16 is 4. And then I can't do anything with the 2 and the 5, so that just stays square root of 10. Okay, so that'd be 2 times 3, which is 6, times 4, which is 24, square root of 10. Now, I'm going to show you the long, tedious way to do this if you don't like that. Again, I would not multiply 18 and 80. Okay, but what could you do? Okay, so I'm going to do this down here, but then I'm going to erase it. Okay, so we have 2, and if you factor 18, I'm not going to show this, you should be able to do it. It's 3 squared times 2, and if you factor 80, it's going to be 2 to the 4th times 5. Again, you can do it using the factoring method I've shown you before. Okay, then what happens? Basically the same thing. You get the square root of 3 squared is 3. The square root of 2 to the 4th is 2 squared. And then the square root of 10 is left over. So we have 2 times 3 times 4 is still 24. And then square root of 10. You're going to get the same thing. It's just easier if you can break it down into the 18 into 9 times 2 and the 80 into 16 times 5. But if you have to factor completely, that's fine. Again, that's what you do when you don't know what to do. Okay, so I'm going to get rid of this. Again, if you want to copy it down, you can just pause the video and copy it down, which is true of any of this stuff, right? Okay, what do you do when you have this? Well, you can take the square root of each one individually, but remember, can you cancel the fraction? Kind of like I did up here, the second way I did number 5. Yeah, why? Because there's no plus or minus, right? So I can cancel the 15 to become 1. Actually, it's the square root of 1. It's still under the radical. And the 60 becomes the square root of 4. And now I take the square, so this becomes the square root of 1 over the square root of 4, which is 1/2. It's the easiest way to do it, okay? Now, something I want to mention to you very briefly. Let's say we had this, the square root of 15 over 60. May I cancel the 15 and the 60? No. Why? Because they're not both under the radical. How about it was 15 over the square root of 60? And you don't need to write these down. I'm just kind of showing you something. No, because they're not both under the radical. How about 15 over 60? Well, hopefully it's pretty obvious you can cancel that. They're not both, neither one's under radical. And up here, they were both under the radical. But when you cancel them, you're not canceling the radical. You're only canceling the numbers under the radical. Okay? So when you cancel these, you don't get 1/4. You get the square root of 1 over the square root of 4. So let me get rid of these. So going back and looking at the original problem, Okay, when you cancel the 15 and the 60, you don't get 1/4. You get the square root of 1 and the square root of 4. And then you take the square root of 1, which is 1, and the square root of 4, which is 2. Okay, let's distribute the square root of 5. Why do we distribute? Because you've got this plus sign right here. Okay, so square root of 5 and square root of 7. I may combine the 5 and the 7. Why? Because they're both under the radical. So that'd be square root of 35. And then square root of 5 times 10. I can't combine those. Why not? Because one of them's not under the radical and the other one is. So it'd just be plus 10 square root of 5. And that's all there is to it. There's nothing you can do with that. Okay, number 14. Can I cancel the 10 and the 20? No. Why not? Because there's the minus sign here, right? If the minus sign wasn't there, if it was like 10, don't write this down, square root of 8 over 20, I could cancel the 10 and the 20. But remember, the thing I've told you is a very good thing to remember. If ever you want to do something, look for a plus or minus, and if it's there, you can't do it. So you can't cancel these, okay? Okay, can you cancel the 8 and the 20? No, why? Because there's a minus sign there, right? So all you can do right now is take the square root of 8. So we'll split 8 up into 4 times 2. And then square root of 4 is 2. Okay? Now, can I cancel the 10 and the 20 now? No. Can I cancel the 2 that's outside the radical with the 20? No. Why not? Because there's a minus sign, the exact same thing as before. If ever you want to take a shortcut and you see a plus or minus, forget it. You can't do it. Okay? You know, you take a look up here at problem number 12. Why can I cancel the 15 and 60? Because there's no plus or minus sign. Okay? All right. But what can I do? Now, this may seem somewhat obscure, but I'm going to scribble something over on the side here. Don't you write it down. If we have 2 times the quantity x plus y, okay, that's the same thing as 2x plus 2y. Well, if I can take 2 and distribute it, I can take the 2 and, not technically correct language, but undistribute it. It's what's called factoring. So is there something in the, let's go back and take a look at this fraction, the problem we're dealing with. And is there something in the numerator that both terms, each term in the numerator has it? Yes, they both have a 2. So I'm going to take the 2 out of each term. And that would, if I take the 2 out of the first one, it just leaves me with the square root of 2. If I take the 2 out of the second one, it leaves me with a 5. Now, may I cancel the 2 and the 20 now? Yes, I may. Why? Because that 2 isn't added or subtracted. Notice I can't cancel the 5 because the 5 is being added or subtracted. The 2 is a factor, and you cancel factors, not terms. Okay? So I can cancel the 2 and the 20, and you get square root of 2 minus 5 all over 10. Okay? So if you have any questions on that, please ask me. There is one more thing I want to go through, but that's the basic idea to simplifying a radical. Okay, last, how do you add and subtract radicals? Well, it's kind of like saying this, and I'm going to write something down. Don't you write it down. 2x plus 5y equals 7. Sorry, not equals, minus 7x. Let's say 7x. Okay, so it's 2x plus 5y minus 7x. Can I combine all 3 of these? No. Why? Because they're not like terms, okay? But these 2 I can combine because they are like terms. So I take 2 minus 7, I combine the coefficients, which gives me negative 5, the x stays there, and then you have plus 5y. There's nothing you can do with that. Okay, that's adding like terms. That's exactly what we're going to do here. Okay, we're going to add like terms with radicals, they're called like radicals, but it's still like terms. So what do we do here? Number one, I add the coefficients. 6 plus 5 is 11, and then the square root of 11 just stays square root of 11. This is like saying 6x plus 5x. That would be 11x. Well, it's just 11 times whatever the radical is, okay? Okay, here we can't do this. Why not? Because the index is the same. They're both square roots, but the radicands aren't the same, so you can't do that. This problem, number 3, you can't do this either. Why not? The radicands are the same, they're 2's, but the indexes are not the same. The first index is a 2, the second index is a 5. Okay, number 4. The way this is written right now, you can't do it. But notice, what I can do is I can split this up. And by the way, you don't have to show me the step. If you want to go straight to calling this 2 times the square root of 2, that's fine with me. On a problem that's simple, you really don't need to show me that. But I'm gonna show it just in case someone's having difficulty. Okay, square root of 8. Again, we'll split it up into things you can take the square root of and things you can't. So this is 7 square root of 2. What's the square root of 4? It's 2 times the square root of 2. Now these are like terms. They're both square root of 2's. Okay? So what's 7 plus 2 is 9, and then times the square root of 2. Okay, hopefully that helps. That pretty much finishes up all the simplification you will have to do in the course readiness. So at this point, you should be able to do all the simplification in course readiness. You're free to go on and look at the equations, but I do want to go through equations first before you touch on those. If you want to work ahead, go ahead and, I'd recommend you read the videos first, but you should be able to do all the simplification in course readiness. Hope that helps. Hope you have a great day. Adios. Or should I say, bonsuelo. Bonsuelo is kind of like, like aloha. It's both hello and goodbye. So I could use it either way. Have a great day. Bye.